Good afternoon. In this midterm event, we would like to introduce our topic simulation data service and data invoice data extraction service with metadata. My name is Thanh from SETLabs Research.
Good afternoon. My name is Maiara Cencic and I am from Fraunhofer-IPK. We start this presentation with a general introduction and placing this content in the overall project context. Then we introduce the simulation as a service and the invoice data extraction service. Finally, going to the demonstration, we present the architecture and process flow that structured this demonstration and the live demonstration. Finally, we present the future steps for this development.
This is our general introduction that we start with the simulation as a service, and then we also introduce the invoice data extraction service. For the placement in the overall project context, simulation as a service belongs to 3.5 engineering and ODTE service, and invoice data extraction service belong to 1.5 payment and accounting. Me and Maiara mainly work on TB1. The next part will be the concept of simulation as a service. This is a framework that enables us to reuse or apply simulation models from other partners without any knowledge about the model itself. I mean, the other partner can reuse our simulation models, for example, Kala ES Mini or run any ALK scenario without the accessing to the model source code. DCP or distributed code simulation protocol can support us. This is the communication standard for the integration of simulation models or real-time systems to the simulation environment. This is the configuration for each service. This is also the only information for other partners to configure to connect to the simulation service. Some basic information here is just the port, the communication port, the IP address of the simulation service, and some basic things like input and output of the simulation service.
In this session, we will present the invoice data extraction service, which is part of the payment module. This is the conceptual model for payment in Gaia X for PLC. So the payment module is what enables the participants to provide their data services and make money out of it. On one side, we have the business models and transactions defined by those participants. This will provide the structure for the smart contracts. The information from smart contracts go through the logging module and then go for billing, payment, and accounting and controlling. While eliciting the requirements for the payment module, we have noticed that most companies still require traditional payment methods, and therefore integrating billing with ERP systems could reduce the adoption barrier for Gaia X. That's why we decided to implement this payment method as one option in the context of this project. To enable that, we needed to develop an invoice data extraction service. Basically, this service gathers information from the contract and from logging, transforms them into the shape of a CSV file, which can be imported by ERP systems, and then generate invoices. In the next session, you will see how the service was used in this demo, showing the architecture and the process flow.
In this part, we will talk about the architecture and the process flow. This is our general architecture. All of the service can be seen in the metadata search and the marketplace. Then we can search for it. After that, we go to the service and start the service via the simulation and the service front end. All of the activities are logged inside the blockchain testers, where we store all of the start and stop logs, and we also use blockchain like registration service. After using the service, we can extract the log, and IDES will extract it, and it also takes some information from the marketplace to generate an invoice. Next part will be the live demonstration. Our demonstration will start with the metadata source and the marketplace, where we try to find our simulation service, and then we go to simulation as a service front end, and then we interact with the Tezos blockchain to start the service. Uh, the service here we use is the Kala service. It works like slave. And the main idea here is we try to share the velocity information from the Kala to the model connect, that we start the app and try to connect with the slave. After using the service, um, we can from the simulation at the service front end, we can go directly to invoice data extraction service, and invoice data extraction service will extract information from blockchain and also the marketplace to generate the CSV file as you see the table here. And this CSV file will be shared to the ERP system to generate a physical invoice for the customer. Here in our demo, we will start with the KX marketplace, then go to the search, then find our data shape. It is simulation service data shape. Then we will try to find all the service with the description color, because color simulator is our main contribution in this event. Then I choose the core detail pay and see all the metadata information of this service. Here we can see the status, hero, and the URL. With the URL, we can access the service via our portal. And here we log in with Bitcoin wallet. We use this because all of the activities in our simulation service are locked inside uh, blockchain. So later on in the future, we also use the Bitcoin wallet to communicate with SSI. And in the service, we can see all the source code of this service. In DCP, the main function is written in C++. Then we use C++ to wrap the Python to call the Python API from Scala. The model description is the configuration and also the guideline for the DCP to communicate with the master and also the slave of DCP. Some of the information can be seen here in the more information. Then we can start the service. It take a little bit of time because it need to look inside blockchain, while blockchain is a bit slow. As you can see, when we start or stop all the activity, we look inside blockchain. Then it will make also the request to the DCP server, and it will start the service at the server side. After starting, you can see some more information like control post, input and or output. Then when we come back to the metadata search, we can see the status change from idle to running. What I just start here is a slave, and here is the guideline or the DCP description of the slave. Then from this, we have to go to the master and reconfigure it to make it communicate with the slave. In this example, our master is model connect. Then we try to look on the velocity of this vehicle in model connect. Now we need to see about the screen of the slave. The slave will run color client. You can see the car now. In the master side, we just start. It also takes a bit of time for the first communication. Now we start. In SETLabs, we also have driving simulator to simulate complicated AR case scenario. As you can see here, the screen is quite small because if I make it become big, so it will generate a lot of lag. With DCP, it's not really 100% of print time, but I think it is quite nearly. And here in this demo, I show how to make the color with driving simulator and then communicate with the model connect via DCP and make driving simulator become a service. Now the simulation complete, and we see until it become finished. Now it complete, and we can go to the result and see, yeah, this is the velocity of the vehicle in the simulation. Then we can just close it and just stop the slave. Now we stop. Then we can come back to the code detail page and see the status now become idle. Now we can go to user history and see how much we use. Then when we choose the bill button, it will go directly to the payment and accounting page where we can see how the service log, the history of service uses log will be mapped to the invoice fields. And from the invoice field, we can generate the invoice. As you can see, we have the machine stop time will be mapped to service date to, or user start time will be mapped to service date from. And the other field can be configured that can be retrieved from the blockchain or with fixed value like currency, like ZD arrow, or some information can be retrieved from the marketplace. Here is an example of the recept, and we also can download it like CSV file and then use this CSV file for ERP system. For the demonstration, we can see here we have a simulation enter service, the first version that we use and configure it to interact with the Tezos blockchain. And we also have another example for simulation enter service and invoice data extraction service with ES Mini and Model Connect. And finally, this is our future work. For the future work of the simulation enter service, we would like to first add selective privacy layer that solves two main problem. All of the data or all of the sensitive data like start service, stop service, historical of service uses or historical of resource uses are stored inside blockchain. All of this data are sensitive and public and accessible. So we would like to hide it and prevent the trackability. Furthermore, for some partner who do not have the simulation infrastructure like Kala with a graphic card. So they need to hire our simulation model, our simulation infrastructure. So we need to find a way to make privacy for sharing data or import data into our infrastructure, and also some model for profit sharing. Another um, future work will be we try to add more modules like model connect. Now model connect is can convert to OpenFX, and we also want to work with OSI, OSMP with sensors. We also try to integrate with other modules like monitoring as a service, and SSI also fully integration with the marketplace. I mean, we can start the service inside the marketplace. This is our expectation, and we also want to collect more requirements from other partners.
As future work in the working group Payment and Accounting, we need to prevent traceability issues due to blockchain logs, which goes in the direction of selective privacy, and we also need to enable alternative payment methods. Finally, we need to implement remaining services that also compose the Payment and Accounting module. Thank you very much for your attention.